In the vastness of the universe, an object from interstellar space has been seen to visit our solar system for the first time. Humanity is still in the early stages of its exploration, having only just begun to delve into the secrets that await us. The prospect of extraterrestrial life has fascinated us despite our limited knowledge, frequently leading to reflection on our cosmic isolation. The arrival of Oumuamua, our first interstellar visitor, changed the course of our story. Our celestial object defied past encounters and left us in awe at the immense potential that exists beyond our Earth. To shed light on this alien messenger, renowned astronomer Neil deGrasse Tyson recently shocked the scientific world by revealing declassified photographs of Oumuamua. In addition to introducing the idea of the YORP effect in the context of Oumuamua, the release of these previously unreleased photographs raises doubts regarding the organizations in charge of sending this mysterious celestial traveler. Rewinding to 2017, a significant discovery altered our perception of the majesty of the cosmos. Rob Warwick used the Pan-STARRS 1 telescope to make what at first glance appeared to be a regular astronomical observation, an unknown object traveling through space toward Earth. Upon closer examination, Oumuamua, the first interstellar object discovered in our solar system, apart from small dust grains, was discovered to be an asteroid or comet. This celestial visitor was given the Hawaiian name Oumuamua, which means, a messenger from afar arriving first, because of its tilted orbit and fast speed, which suggested an origin that was far outside of our solar system. The peculiarities of Oumuamua, like its erratic brightness fluctuations, were immediately identified by astronomers and were difficult to explain. Its elongated shape, which is said to be 5 to 10 times longer than it is wide, sparked conjecture on its origin and function. According to one theory, Oumuamua may have been stretched into its odd cigar-like shape by tidal forces close to its star. Even though it's still difficult to explain certain dimensions, astronomers look to similar objects in our solar system, such the asteroid 2543 Itakuwa, which the Japanese Hayabusa mission encountered in 2005, to better understand the shape of Oumuamua. Although Itakuwa and Oumuamua are somewhat similar, the interstellar visitor is nevertheless distinguished by its lengthy proportions and lack of a tail. Like a bicycle suddenly gaining speed without pedaling, Oumuamua's acceleration added an intriguing depth to its mystique. From above the flat plane on which planets circle, Oumuamua entered our solar system, heading dangerously near the Sun before continuing below the planetary plane. Surprisingly, Oumuamua continued to travel at an exceptionally high speed, hitting almost 196,000 kilometers per hour, faster than any object ever launched by a human. Because of its extraordinary speed, it has been suggested that Oumuamua might have come from a double star system, adding fresh information to the ongoing study of the cosmos. According to the idea, objects in binary star systems may be ejected at high speeds due to gravitational interactions. It is conceivable that the gravitational pull of the stars drove Oumuamua on its interstellar journey, which explains its extraordinary speed, if it did indeed come from such a system. It is also possible that interactions with other celestial bodies in its native star system contributed to Oumuamua's velocity. Oumuamua may have reached its observed velocity due to gravitational slingshots from encounters with planets or other large objects. Space missions frequently use this process to increase speed during flybys by harnessing the gravitational pull of planets. To ascertain the possibility of such interactions and their role in Oumuamua's velocity, more investigation is required. However, Oumuamua is more than just its speed. Exciting details regarding its composition have been uncovered by studies. It has a thick outer layer that resembles a cosmic shell and is composed of components rich in carbon that crystallized as a result of cosmic radiation throughout its lengthy journey across interstellar space. The extraordinarily thick core composition of Oumuamua, which is mostly formed of rock and may contain components of metal, is revealed beneath this protective covering. It is different from ordinary comets or frozen celestial bodies since it does not contain water or ice. Furthermore, the surface of Oumuamua has a crimson hue due to hundreds of millions of years of exposure to cosmic radiation. Researchers have also speculated that the form and composition of Oumuamua may be responsible for its extraordinary speed. However, a number of people have asked well-known specialists like Michio Kaku and Neil deGrasse Tyson to add their insights to the conversation on Oumuamua. It's interesting to note that Neil deGrasse Tyson remained silent about the issue until significant proof and the recently released declassified images were made public, so everyone was anxious to hear his thoughts. Some scientists speculate that the item may be a piece of a larger body because of its elongated shape, which can be deduced from its light curve. In the event that Oumuamua separated from a larger object as a result of a collision or other severe incident, it may have gained significant velocity in the process. This would suggest that Oumuamua's speed is a product of past events rather than anything inherent to its nature. For example, comets move across our solar system at different speeds. Some comets, like Comet Hale-Bopp, can reach speeds similar to Oumuamua, but because of their volatile makeup, they usually show lingering gas and dust. Oumuamua, on the other hand, showed no such traits, setting it apart from other known Keter objects. The rocky objects known as asteroids, which orbit the Sun, provide another analogy. In comparison to Oumuamua, the majority of asteroids in our solar system travel at far slower speeds. The well-known asteroid series, for example, has a typical orbital velocity of about 17,880 km per hour, which is less than a quarter of Oumuamua's projected speed. This discrepancy highlights how unusual Oumuamua's speed is and how it differs from other well-known solar system objects. This is where the situation gets even more interesting. According to some analysts, Oumuamua might be more than just a naturally occurring item. They speculate that it could be a carefully constructed artificial object, the product of a highly developed extraterrestrial society. Oumuamua might be a component of an extremely sophisticated extraterrestrial spacecraft or equipment intended for exploration. This notion suggests that the special qualities of Oumuamua may have several uses. Its propulsion system could allow for precision navigation around the cosmos, while its elongated form could increase its robustness during interstellar flight. This idea is firmly held by well-known individuals such as Israeli-American theoretical physicist and astronomer Avi Loeb. Loeb even put up the contentious theory that Oumuamua might be extraterrestrial in origin, speculating that it might be a man-made item or possibly an alien technological device. He maintained that its odd characteristics, like its remarkable acceleration and elongated shape, might point to an artificial origin. The scientific community engaged in extensive discussion and debate as a result of Loeb's hypothesis. It's crucial to remember, though, that a lot of astronomers and scientists have voiced doubts about his assertions. The majority of scientists believe that Oumuamua is probably a natural object, like an asteroid or comet, and that natural processes are responsible for its peculiar characteristics. Wesley C. Fraser and colleagues examined a rotation period by combining brightness observations from several telescopes. They came to the conclusion that the observed changes in brightness could not be explained by any rotating time. Rather, the object seems to be in an energized rotating condition, tumbling. There had never been anything like this strange, odd tumbling action. Since its discovery, experts have been perplexed by this erratic rotation. Astronomers' observations have shed important light on the rotation of Oumuamua. In comparison to other objects in our solar system, it rotates very quickly, completing a full circle every 7.3 hours. Its brightness also changes dramatically as it rotates, suggesting that different components of the object reflect sunlight to differing degrees. Scientists have been puzzled by this erratic rotation, which has given rise to a number of fascinating theories. It has been suggested that the spin-induced outgassing theory explains Oumuamua's spin. This theory holds that when the object tumbles through space, volatile materials beneath its surface are exposed to solar radiation, vaporizing and producing small gas jets. By acting as thrusters, these jets provide Oumuamua a torque that makes it spin erratically. This suggests that volatile elements that are prone to sublimation under the impact of solar radiation may be present in the composition of Oumuamua. To determine whether this process is in charge of Oumuamua's odd rotation, more research is necessary. According to a different theory, Oumuamua may have been tumbling because of a previous collision with another object. It could have been thrown into an erratic spin by a high-speed impact that deformed its shape. The object may have been blasted into interstellar space after a collision in its native star system. However, due to a lack of observational data, the precise nature of such a collision and the object involved are still unknown. A thorough examination of the chemistry, surface characteristics, and shape of Oumuamua may yield hints in favor of this theory. Let's look at other celestial objects that exhibit similar behavior in order to better understand Oumuamua's odd movement. The asteroid 40-79 Taurus is one example. This long asteroid, which was found in 1989, exhibits a tumbling motion similar to that of Oumuamua. The YORP effect is one among the explanations put forth by scientists to explain Taurus's unpredictable rotation. This effect states that because of the unequal temperature radiation from sunlight, the item experiences a torque. Gradually, this torquing action causes the asteroid to rotate differently, which causes its erratic tumbling motion. Although the precise function of this mechanism is still unknown, it may also apply to Oumuamua. Remarkably, 67P/Churyumov-Gerasimenko, another comet, likewise exhibits an erratic rotation. On September 11, 1969, scientists made the discovery of 67P, also known as 67P/Churyumov-Gerasimenko. This comet, which revolves around the Sun, has a remarkable form and unique motion. It has a distinctive look that is frequently likened to a rubber duck or a bowling pin because of its two separate lobes joined by a slender neck. In roughly 6.45 years, the comet's elliptical orbit completes one cycle around the Sun. It is a member of the Jupiter family of comets, meaning that the Kuiper Belt, a region of icy bodies beyond Neptune, is where it originated. Nonetheless, scientists think that 67P was drawn into its present orbit by gravitational disturbances brought on by Jupiter's powerful gravity. The velocity and distance from the Sun of this previously examined comet fluctuate in different ways. Scientists believe that a major factor in the tumbling motion of Oumuamua is the outgassing of volatile chemicals from the comet's surface. The comet's rotation is changed when the ice on its surface vaporizes due to solar radiation, producing localized jets that function as thrusters. The resemblances between these objects and Oumuamua suggest that there may be underlying causes causing their peculiar spins. Additional investigation and thorough examination of these items can yield important information about the nature of Oumuamua. Tyson's theories have a wide range of applications, from philosophical reflections to technical breakthroughs. They challenge accepted astrophysical theories and have the potential to change how we perceive the universe. A major paradigm shift and the beginning of a new age of space exploration would result from the validity of any of his theories. Thank you for viewing. Take a look at the incredible video that is currently playing on your screen.